Okay, let's do some classwork problems for paired t-tests. All right, so this is when we have dependent samples. And for these three problems that we're going to go through, I just have summarized data. It's going to look a little bit different in the homework. So as we go through these problems, I'm going to explain to you how it would look in the homework in a data file so that you can pick it out that it is in fact a paired t-test. Okay, the biggest issue in my experience with this next exam is you distinguishing between a two-sample t-test and a paired t-test. All right, and I think what we're going to see here is that as we go through this, just like I did with the two-sample classwork, I'm really going to try to point out what makes these paired t. Okay? All right, so let's get started with this first problem. Oh, and again, all you need open is the 292 paired t classwork document, as well as a blank Minitab file. All right, and that's all we need to do these three problems. All right, number one. A teacher claims that a grammar seminar will help students reduce the number of grammatical errors they make when writing a 1,000-word essay. The table shows summary statistics for the number of grammatical errors made by 7 students before and after participating in the seminar. At the 5% significance level, is there enough evidence to conclude that the seminar reduced the number of errors? All right, so this is classic paired t. All right, and what do I mean by that? I mean that it is a before and after scenario. All right, we've got a before count on grammatical errors, we have some kind of intervention, and then we have an after count on grammatical errors. And we want to know, did the seminar help? Okay. All right, so we are, as stated here in the summarized data, we are defining the difference as after minus before. Okay? So we want after to be fewer than before. Okay, so again, we want the grammatical errors after to be less than before. So this means that what we want to test with the alternative is that mu d, or mu difference, all right, and again, there's just one mu in a paired t-test, and that mu is mu with a subscript of a d or the word difference, okay? So mu difference less than 0, okay? Why less than 0? Because we want to test if after is fewer than before. So if we were to subtract a small number from a bigger number, we would get a number that is negative or less than 0. Okay? And are you maybe confused right now? Of course. All right, just stick with it through these three problems. Hopefully it gets a little bit more clear. You may want to listen to this twice just for it to click. And if you get through the homework and it still hasn't clicked, feel free to reach out to me and we can work through some more problems. All right, so if our alternative is mu d less than 0, then our null is mu d, as we know, greater than or equal to 0. So I need to insert a symbol here. All right, so greater than or equal to 0. Okay. All right, so now we can go into Minitab. All right, and this is a paired t. So how do we know for sure it's paired t? All right. First and foremost, with the summarized stats, I only give you one column, which is a difference column. Okay. It is after, we have a before-after scenario. That is those are dependent samples. Okay. There is no information in the problem on what to assume with the population variances or standard deviations. Notice here in problem 1 that nowhere do we read assume population standard deviations are equal or unequal. All right, that is something that tells you that it is a two-sample t-test. Okay, so here this is a paired t, so we are going to go into two-sample paired t. All right, and let's first talk about this drop down here. All right, so in the homework, you're going to have each sample is in a column. Okay, and then for these three problems in the classwork, we're going to have summarized data differences. Let's talk a little bit about each sample is in a column. What would it look like if we had data for this problem? All right, so we would have a, let's see here, a student, a before, and an after column. So student 1 had maybe 20 grammatical errors before the seminar and 14 errors after the seminar. Student 2 had 13 errors before and 12 errors after, and so forth. All right, and we would just keep going down for each student a before and after count on grammatical errors. All right, so here's another clue or key that it is a paired T problem. If I give you a data file, I have to give you at least 3 columns. Okay, so the data columns or our samples are here in the before and the after columns. But I have to give you a third column, just like you saw in the PowerPoint video, that links the 2 columns before and after. So this 20 and this 14 is linked by student 1. Those numbers belong to student 1. All right, this 13 and this 12 belong to student 2. All right, so again, look for 3 or more columns when it is a paired T and you have a data file. All right, so let's work this first paired T problem. We have summarized data. All right, our sample size is 7. Our sample mean is negative 3.14. Our standard deviation is 2.04. All right, we go under options. All right, and again, we have to pay attention to how Minitab defines the difference, okay, when we have data. For these problems, we are not going to need to, all right? I have, in giving you the summarized data, I've taken that away. But when we actually have columns of data, we have to pay attention to how Minitab defines the difference, all right? All right, and our alternative hypothesis here is less than 0, all right? And we can ignore the confidence level and say okay. All right, so notice Minitab also gives us a mu d. So again, with paired T, there's only one mu, and it's a mu d. All right, the mean difference, the population mean difference. All right, so our alternative here in Minitab matches what we have in our Word document. All right, our p-value is 0.0033. All right, so what's our decision based on that p-value? Since 0.0033 is less than 0.05, we reject the null hypothesis. All right, what does it mean for this problem to reject the null? There is enough evidence to conclude that the seminar reduced the number of errors. All right, so in other words, from a statistical standpoint, the seminar worked. All right, it significantly reduced errors. All right, number 2. An SAT prep course claims to improve the test scores of students. The table shows summary stats for the critical reading scores for 10 students for 10 students the first 2 times they took the SAT. Before taking the SAT for the second time, the students took a course to try to improve their critical reading skills. Test the claim at the 5% significance level. All right. So we got a null, we've got an alternative. All right, so now, and let me go back up here and talk about this difference. Okay, so the difference is defined as after minus before. All right, so now what we want to test is if scores are higher after than they were before. So we want to do a big number minus a smaller number. So that gives us an inequality of greater than 0. Take a big number, say 5, minus a smaller number, say 3, and you get a positive number. All right, so that means that our alternative here is that mu d is greater than 0. That makes the null mu d, and we need our symbol, less than or equal to 0. All right, so we go into two-sample paired t. We know this is paired t because, again, it is a before and after scenario. All right, if we saw this information as data in a file, it would look just like I have started typing down here. We would have a student column, we would have a before critical reading score, and then we would have an after critical reading score, so that those scores would be linked on a student. And we do not read any information about the equality of the population standard deviations or variances. All right, so we have summarized data. We type in what we see in our table here. All right, so we've got the sample size, mean, and standard deviation. We'll go under options and we need to change our alternative to greater than 0. We can ignore confidence level and say OK. All right, again, the alternative in Minitab matches what we have typed in our Word document. Our p-value is less than 0.001. Again, as a reminder, in Blackboard you cannot type the less than, so you would just type 0.0001. All right, what is our decision? Since 0.0001 is less than 0.05, we reject the null hypothesis. What does that mean for the problem? There is enough evidence to conclude that the course improves critical reading scores. And you could say improves or increases. All right, so there's several ways we could say that. All right, last problem. A nutritionist claims that a particular exercise program will help participants lose weight after 1 month. The table shows summary statistics for the weights of 12 adults before and 1 month after participating in the exercise program. At the 0.05 level of significance, can you conclude that the exercise program helps participants lose weight? All right, again, we have a before and after scenario. Okay, we do not get any information about the equality of population standard deviations or variances. All right, so we know this is going to be paired t. The difference is defined as after minus before. All right, now what do we want to test? We want to test if people lose weight, right? We want to test if they lose weight. So their weight after is less than their weight before. If the weight after is less than their weight before, then what we are testing is that mu d is less than 0, because we're taking a small number minus a bigger number, and that gives us a negative number. All right, the null would be mu d. Let's see, I've got a greater than or equal to up here. Just copy it. All right, so our null there is mu d greater than or equal to 0. All right, we can go over to two-sample paired t, summarize data, and we can put in our sample size, our mean, difference and our sample standard deviation for the difference. Under options, we need to change our alternative to less than 0 and say OK. All right, so we get a p-value of 0.0629. So since 0.0629 is greater than 0.05, we fail to reject the null hypothesis. Okay? So there is not enough evidence, let's see here, to conclude that the program decreases weight. All right, so what's happening here, and let me just step back for a second and help you understand. When we look at all the differences between the people, we get a sample average difference of negative 3.75. And so what the statistical test is asking is negative 3.75 a significant difference? All right, so is losing 3 3/4 pounds significant? All right, and what we find with our p-value is that it's not. It's an arithmetic difference, okay? It's an arithmetic difference, but it's not a statistical difference. It's not far enough away from 0 to say that after is significantly less than before. Okay, so that's kind of what's happening here statistically. All right, at this point, you're ready to try the homework, and let me know if you have any issues getting any of the answers in the key.